Alright, our first module is about radicals, and the first topic in that module is an introduction to radicals. So we're going to go through all the vocabulary and all the simple math knowledge you're going to need to help you succeed in dealing with these new monsters. Okay, so the first definition is about the square root, which is probably the simplest type of radical. The principal square root of a number a, written as square root of a, so the square root symbol is this almost check mark looking thing. The principal square root of a number a is a positive number b. Okay, so the principal square root of a number a is going to be a positive number b that gives back a when multiplied by itself. So in math speak, the square root, the principal square root of a number a is equal to b exactly when a is actually a product of b times b. So for example, the square root of 16 is equal to 4 because 16 is equal to 4 times 4. I've noticed that students have trouble with radicals at first, and one of the reasons I think this is because radicals are actually a reverse operation. Okay, it's the same reason that students have trouble with negative numbers at first, because negative numbers are a reverse operation to addition. So anyway, radicals undo exponents. Radicals are the reverse operation to taking an exponent. So for example, the square root operation will undo the squaring operation. Right? If you look at this, if you take 5 and you square it, you get 25. But if you start here and you take 25 and you square root it, you get 5. So if you square and then square root, it gets you back where you started. Right? So if I write square root of 25, I want to see 5, right? Because 25 equals 5 times 5. Right? So the square root of 25 is 5. Right? Another way of saying 25 equals 5 times 5 is saying that 25 is 5 squared. Okay, so radicals and exponents are reverse operations. They undo each other. All right, we'll be talking about that more as this module goes on. There's a lot of theory behind roots and radicals, and there's a lot of mathematical symbols and a lot of sort of terminology to get lost in. Okay, but when it comes down to it, we need to know exactly what a square root does. Right? So what a square root does is it takes a pair of factors and turns them into a single factor. Okay, so for example, the square root of 49 is going to take the pair of 7s that are factors of 49 and turn them into a single factor. Okay, the square root of 36, okay, if you think about it, you know 36 is 6 times 6. So the square root of 36 is going to take this pair of factors and give a single factor back. The square root of 81, you know 81 is 9 times 9. So the square root of 81 is going to take this pair of factors and turn it into a single factor. Okay, so square roots take pairs of factors and turn them into single factors, which means if you can factor your number down, if you can factor this number underneath the square root into a pair of factors, then you can find its square root very easily. So the goal with square roots is to turn the number underneath the square root into a pair of factors, so then you can just take one of those factors to get the square root. Okay, so the idea of a square root can be generalized. Okay, instead of looking, for the square root of 16, which means we're looking for a pair of factors, a pair of identical factors in 16, we can look for maybe the fourth root of 16, which means instead of looking for a pair of identical factors, we're looking for 4 identical factors that multiply out to be 16. Okay, so this is the definition of that generalization. The nth root of a number a, written as the square root symbol with a little n, this is called the index. The nth root of a number a is a number b that gives back a when multiplied by itself a total of n times. So the nth root of a is equal to b exactly when a is equal to b times b times b times b times b n times. So another example, see, to help you digest this, the cube root of 64, well, to find the cube root of 64, you're looking for a group of 3 identical factors that multiply out to 64. So if you think about it long enough, you'll see that 4 times 4 times 4 is 64. So the cube root of 64 is 4. You can do the cube root of, right, so when it's a 3 we call it a cube. I snuck that in there. You can do the cube root of 125. You would be looking for a group of 3 identical factors that multiply out to 125. So 5 times 5 times 5 is 125. So the cube root of 125 is 5. So there's a root for any whole number. There's a third root or a cube root, a fourth root. There's fifth roots. The fifth root of 32, for example, means we should look for a number that multiplies by itself 5 times to give you 32. So we're looking for a group of 5 factors that multiply to 32. And so hopefully you can see that 2 times 2 times 2 times 2, 5 times, is equal to 32. So the fifth root of 32 is going to take these 5 2's and give you back a single 2. Okay. So this is just generalizing the idea of a square root, and it's just looking, you're going to be looking for groups of identical factors that are bigger than 2. So here we're looking for a group of 4, a group of 3, a group of 5, etc.